Okay, so now here's another one. This one's called the quotient rule. The quotient rule looks slightly more complicated, but essentially says the same kind of idea, and it's this. If we were to take the derivative of a quotient of two functions, f of x over g of x, then our derivative will equal to g of x times the derivative of f of x, so the denominator times derivative of the numerator, minus the derivative of the denominator times the numerator function, divided by the square of the denominator this time. There's again a proof of this that will be done separately, as long as the denominator is not equal to 0. So let's pick a function where the denominator will not be 0 over the set of real numbers and try it out. And of course, you can see that we have in our numerator the function f, and in our denominator the function g. So, by our rule, our derivative, dy dx, will be equal to the following. Big fraction bar right here so I can work this out. G of x. G of x is x squared plus 1. So we're going to have x squared plus 1 here in the numerator. We're going to multiply that by the derivative of the numerator, the derivative of 2x minus 1 here. So I'll write that so I can see it, dx of the quantity 2x minus 1. And we're going to subtract from it this time the numerator, the derivative of the denominator times the numerator. So I'm going to go ahead, I'm going to put that numerator first. So I'm going to take 2x minus 1, and this time I'm going to multiply it by the derivative of my denominator, so x squared plus 1. And we divide that by the square of the entire quantity in the denominator. Now, remember, x squared plus 1 squared is not x squared squared plus 1 squared, right? We'd actually have to FOIL that out if we we're going to do that. But we're going to leave it in this form. We're not even going to change it. We're going to just leave that quantity squared. And so our derivative is going to look like this. X squared plus 1 in the numerator will be multiplied by the derivative of 2x minus 1. Well, that's just 2. Minus our quantity 2x minus 1 times the derivative of the function in the numerator. In this case, that's just 2x. And we're going to divide that by our quantity x squared plus 1 squared. Now I will definitely simplify this, so let's go ahead and distribute. So I'm going to take 2 times x squared plus 2, and we're going to subtract from that 2x times 2x, that's 4x squared, minus negative 1 times 2x, so that's plus 2x. And all of that is over x squared plus 1, quantity squared, which we're going to leave that way. And so our derivative, when we combine all of our like terms, will look like 2 plus 2x minus 2x squared, all divided by x squared plus 1 squared. And you see that one thing that we're doing is we're using our rules for simplifying fractions. If there were any further common factors in the numerator and denominator, we would certainly factor and cancel. There aren't any more right here. This is our reduced or our simplified derivative, and so we're going to leave it that way. There we go.